Welcome to Physics Can Be Fun with me, Stephen Thomas. In my last video, I talked about revolutionary science teaching. Science teaching that should be fun. Now, I emphasized we don't spend the lesson giving notes and we don't spend the lesson sitting on our calculators doing problems. Problems and maths, we can go to my webpage, it's got all the formulae, punch in the values, it does it for you. So what are we going to spend our time doing if we're not sitting there taking down notes, which is counterproductive because we want to get it into our memories. So we want the kids to get everything in their memories. There's not much to remember. So why are we training them to not remember, put it in their notes when we want them to remember it now and keep on revising it? Every few weeks we revise. We don't need the notes. And there's not much in paper one matric that they have to remember. So if we're going to not be giving notes, not be sitting doing maths, we're going to be having fun. Now I said to get stuff into our memories, let's act out the problem. So let's say we start with question on projectile motion. We said that's the start. We throw a ball up, we act it out, get the whole class to act out, there the ball falls down. Now there's one thing that is more fun than acting out a ball being thrown into the air, and that is actually taking a ball and throwing it into the air. So I've drawn lines with 10 centimeters between them, and I'm videoing throwing this golf ball up. And here we have an actual projectile, and we're recording it, and now we can actually study vertical projectile motion in the real world with an actual video. So what I did was I filmed this, then I uploaded it to YouTube. All the kids could do that. They can video it on their phone, create a little video. I chose the best little clips that were within this range, and let's go to the computer and have a look what we can do with it. Right, here we have our YouTube video, and here I've opened a spreadsheet using the internet docs.google.com/spreadsheet. And if we go to this video and I press full stop twice, you'll see that it brings the frame of the ball being thrown up. I'll press twice again, and each time it moves by one frame up, and you'll see that the ball, and I can press comma to go backwards, and there we see that this trail represents the velocity of the ball, and each time we press the full stop twice to move it forward, that trail gets shorter. So this is how we visualize velocity. Now if you want to visualize acceleration, I'll press it again. It's the change in the length of this displacement per frame over time. So I'll press the comma to move it back again. That's how long it was in the previous frame, and that's how long it was in the next frame. So that represents velocity, and acceleration is the change in the length of the tail divided by time. So just going back, we started with the top of the ball there touching the 3, and I filled in the value here on our spreadsheet, 0.3 of a meter or 30 centimeter mark, 0.3. Now notice it goes 20, 30, 40, 50 as we go up. So we've chosen upwards as positive throughout this whole problem. Now if I go back to this spreadsheet, there you'll see it, I'm throwing it. And if I go all the way back here, and I press the full stop, there's the next frame, 0.46, and here we've put it 0.46, full stop again, 0.59, there, 0.59, 0.67, there, at the top of the ball, 0.67, 0.7, 0.7, 0.71, you can see it stopped, 0.71 there on the spreadsheet. And now we were measuring from the top of the ball, so we estimate where the top of the ball is there. It's about 0.64, 0.64. Now it's at about 0.54. There is the top of the ball about there, 0.35. And now the top of the ball is there, 0.15 meters, just above the 10 mark, 0.15 meters. So here we have our displacement values. Here we have, if we subtract the final minus the initial displacement, we get a change in displacement, or delta y. So that one minus that one gives us that value. And then if we divide it by time, the time for each frame, which is 1/15 of a second, here we're getting a velocity. I've just moved the spreadsheet a little closer to the YouTube video. So here we have our velocity. Here we have our change of velocity. And here we have our change of velocity divided by time, or acceleration. And this value here represents the average of all of these changes of velocity, and which we see is minus 10.12, which is as close as anything to minus 9.8. Now here we've turned our displacement time graph into a line graph. Let's delete that. And if we were to take our velocity values, highlight those, insert chart, here we see our velocity time graph. So a very useful tool, using a spreadsheet together with a video to explain and to examine projectile motion.